Hello. The lead code problem today is Graph Bipartite. So let me read the description. There is an undirected graph with n nodes, where each node is number between 0 and -1. You are given a 2D array graph, where graph U is an array of nodes that node U is adjacent list. More formally, for each V graph, there is undirected edge between node U and node V. Yes. The graph has the following properties: no cell edge, okay, and no parallel edge, cannot contain duplicate values, does not contain, okay. If V is in graph U, then U is in graph V, okay. The graph may not be connected, meaning there will be two nodes U and V, such that there is no path between them. I'm thinking, okay, this graph bipartite if the node can be partitioned into two independent sets, such that every edge in the graph connects a node Z A and node Z B. Partition edge in the graph connect. So that means an edge will divide two nodes, connect with that into two parts. So for example, if the first node, the node 0 is part A, so all of each child will be part B, like node 1, node 2, node 3 will be part B. Output 4, there is no way partition. You can set every edge connect a node in one and a node in the other. Okay. Okay. 0, 2, 1, 3. Oh, it's right. Okay. So my initial thought it will be, as I said before, an edge will divide two nodes, two vertices of that edge into two parts, and we will do a DFS through all the vertices and check whether there is a conflict or a node that belongs to both part A and part B, and we will return false. Otherwise, we will return true. So I think this is DFS. So time complexity will be O vertex multiplied with edge space complexity. I think I will use two hard set to store which node belong to which part, but the total number of nodes of the two hard set will not exceed the amount of edge. So I think it will be O vertex, and the solution is as I said before. So I will try to implement that. We have a hard set int set A because DFS we also need a visited array. Will be graph.lang. The input will be node And okay, uh, we will loop through the graph. Uh, if we do DFS with this, okay, so we check in here. Visited node equal to true, and I will have to set a bool here to check which path this node belongs to. Is path A equal true? So if set A contains node expression, okay. I think this line is a bit redundant. We don't need that line, but okay. B contain node A false. What will be next? Let's see. We'll do a for loop here. For each in if is part A, so this node will be added to part B. Set B up, or if that is not part A, and we will add this node to part A. I'll have to check that to avoid error. And if visited and false, we will DFS and is it enough? I think is it enough? I think I will separate these two logic to avoid add cage. Or not? I don't think whether we need that or not. So if we add that and we just, I don't think we were gonna need to separate the logic into two different loops, because if it conflict, it will be conflict. Okay, do another loop here. If A contains A, return false, otherwise return true. Let's see if that works. Oh, okay. Okay. Oh, hmm. Hmm. Hope that's gonna work. Okay, great. Wow.